What if the oldest libraries in the universe aren't made of paper but of ice and dust? That's exactly what comets are. Not just wandering snowballs tumbling through space, but frozen archives, time capsules carrying the raw, untouched ingredients from the birth of our solar system 4.6 billion years ago. Think about that? Before Earth cooled, before oceans formed, before the first single-celled organisms emerged, comets already existed. And somehow, after billions of years, many of them remain virtually unchanged, holding secrets that planets, with all their volcanic activity, tectonic shifts, and atmospheric storms, long ago erased. When you see a comet streak across the night sky, glowing with a tail that stretches for millions of kilometers, you're not just watching a pretty celestial show. You're witnessing a messenger from the dawn of creation, an object older than Earth itself. To understand comets, we need to travel far beyond the planets, past Jupiter, Saturn, Uranus, Neptune, out into the icy wilderness at the solar system's edge. There are two great reservoirs of comets. The Kuiper Belt, a disc-shaped region beyond Neptune filled with icy bodies. It's the source of short-period comets, those that orbit the Sun in less than 200 years. Pluto itself is a Kuiper Belt object KBO. The Oort Cloud, a vast, spherical shell of icy debris that may extend halfway to the nearest star. It's thought to be the birthplace of long-period comets, those that take thousands, even millions of years, to complete a single orbit around the Sun. These regions are like deep freezers, preserving ancient ices and dust grains from the time the planets were forming. While Earth and Mars underwent violent transformations, comets sat in deep freeze, waiting for a gravitational nudge from a passing star or the pull of a giant planet to fling them inward. And when they come close to the Sun, that's when the magic happens. At first glance, a comet seems simple, but up close, it's surprisingly complex. The nucleus, the solid heart of a comet, usually just a few kilometers across, it's made of rock, ices, frozen gases, and dust. Darker than coal, the nucleus reflects very little sunlight. It's this core that scientists desperately want to study because it's the untouched material from 4.6 billion years ago. The coma, when a comet gets close to the Sun, solar radiation heats the nucleus. Ices sublimate, turning directly from solid to gas. A giant cloud of gas and dust surrounds the nucleus, sometimes tens of thousands of kilometers wide. The tails, yes, tails, plural. Comets usually have two: a dust tail, which curves gently along the comet's orbit, and an ion tail blown straight back by the solar wind, glowing blue from ionized gas. These tails can stretch millions of kilometers across space. Every part of this anatomy tells a story about the early solar system. The dust grains match the building blocks of planets. The ices reveal what kinds of molecules were common in the Sun's nursery. And the gas tails show how comets interact with solar radiation. For decades, people thought comets were just dirty snowballs. But modern missions have revealed something far richer. Inside comets, we've found water ice, carbon dioxide, methane, ammonia, and even complex organic molecules, the very building blocks of life. Some comets even contain glycine, the simplest amino acid. Others show traces of tholins, reddish compounds created by radiation interacting with organic matter. These discoveries rocked planetary science. They suggested that comets may have been more than just spectators in Earth's history. They might have been participants. Comets and the origin of life. Here's where it gets profound. Billions of years ago, Earth was a harsh, barren world. Volcanoes erupted constantly. Asteroids and comets bombarded the surface. The oceans were just beginning to form. What if, during that chaos, comets delivered the chemistry of life? In 2014, the European Space Agency's Rosetta spacecraft made history. It deployed the Philae lander onto Comet 67P, Churyumov-Gerasimenko. Though Philae's landing was rough, it bounced multiple times and ended up in shadow. The instruments worked long enough to make a stunning discovery. The comet contained organic molecules, including amino acid precursors. The same chemistry that life on Earth depends on was hiding in a frozen relic billions of years old. Think about that. Comets could have seeded Earth with the ingredients for life. Every impact, every shower of cometary dust may have been delivering water, carbon compounds, and amino acids to our young planet. Some scientists go even further. They suggest that panspermia, the idea that life itself, or at least microbial precursors, could travel between worlds on comets, might not just be science fiction. It's possible that the spark of life didn't start on Earth at all, but arrived here riding a comet. Water from the sky. Comets may also explain why Earth has oceans at all. When isotopic fingerprints of hydrogen in cometary ice were measured, some matched the ratio found in Earth's water. That means at least part of the water we drink today might have come from comets crashing into Earth billions of years ago. Imagine, the glass of water in your kitchen could trace its origin to an icy wanderer from the edge of the solar system. But comets aren't all the same. Some behave like classic icy snowballs. Others carry strange compounds never seen before. Some glow with unusual colors or break apart mysteriously. And then there are the true outliers, objects that look like comets but don't play by the rules. Which brings us to one of the most exciting mysteries of the past decade. In 2017, astronomers spotted the first confirmed visitor from outside our solar system. An interstellar object traveling too fast to be bound by the sun's gravity. At first, it looked like a comet, but then it broke the rules. No visible tail, no water, just silence. It was given a name, Oumuamua, a Hawaiian word meaning scout or messenger from afar. And it was only the beginning. What happens when something enters our solar system that doesn't belong here? Not from the Oort Cloud, not from the Kuiper Belt, but from the stars. In October 2017, astronomers using the Pan-STARRS telescope in Hawaii detected something racing across the night sky at an impossible angle. At first, they thought it was a faint asteroid. But within days, the data revealed something extraordinary. This was no ordinary rock. It wasn't orbiting the sun like a planet, or even swooping in like a comet from the Oort Cloud. Instead, it was passing through. Humanity had just spotted the first confirmed interstellar object in history. Its name, Oumuamua, a Hawaiian word meaning a scout from afar, arriving first. At first glance, it seemed comet-like, but as astronomers studied it, the puzzle only deepened. Unlike a comet, it had no visible tail, no gas jets, no glowing halo. Unlike an asteroid, it was speeding up slightly as it left the solar system. Something was pushing it, but what? Its shape was bizarre. Some models suggested it was a long cigar-shaped rock, tumbling end over end. Others argued it was flat, like a cosmic pancake, thin and wide. And then there was its color. Oumuamua's surface appeared reddish, similar to tholins, complex organic compounds that form when cosmic radiation bombards icy worlds for billions of years. For decades, astronomers dreamed of finding interstellar travelers. Now one was right in front of us, and it refused to fit into any category. Was Oumuamua a comet without a tail? One theory suggested that Oumuamua was a comet, but an unusual one. Instead of releasing water vapor like most comets, it may have been releasing hydrogen or nitrogen ice. These gases are nearly invisible in space and could explain its strange acceleration. If true, it might have been a fragment of a Pluto-like world, shattered in another star system and ejected into the galaxy. Imagine a shard of an alien planet wandering for eons before crossing our skies. But there was a problem. If Oumuamua were made of nitrogen ice, it would have eroded away long before reaching us. Hydrogen ice was another possibility, but again, could it really survive a journey of millions, maybe billions of years? Alien technology. Not everyone was convinced by the icy fragment theory. Harvard astronomer Avi Loeb put forward a radical idea. What if Oumuamua wasn't natural at all? He suggested it could be a solar sail, a thin sheet of artificial material pushed by starlight itself. The strange acceleration, the odd shape, the lack of gas jets, all could be explained if it was a piece of alien technology. Most astronomers remain skeptical. Extraordinary claims require extraordinary evidence, and so far there's none. Still, the idea captured the public imagination. For a moment, Oumuamua wasn't just a rock, it was a messenger, a possibility, a question mark written across the stars. Then, in 2019, just 2 years later, another object arrived. This time, it was unmistakably a comet. Discovered by amateur astronomer Gennady Borisov, Comet 2 Borisov streaked into the solar system with a glowing coma and long tail. Unlike Oumuamua, it behaved exactly as expected, a dirty snowball venting gas as it neared the sun. But its chemistry, that's where things got exciting. Borisov's ices contained high levels of carbon monoxide, far more than typical solar system comets. Its composition suggested it formed in a much colder, more distant environment than anything near our sun. In other words, we had proof that other star systems make comets too, and they don't all look like ours. What do interstellar visitors tell us? These two travelers, one puzzling, one familiar, opened a new era of astronomy. Oumuamua hinted at strange physics, exotic ices, or even artificial origins. Borisov confirmed that icy comets form naturally around other stars, carrying unique chemical signatures. Together, they suggest our galaxy may be filled with wandering debris. Planets shatter, stars die, comets get kicked out of their systems and drift for billions of years, waiting to be found. Some may carry nitrogen-rich volatiles. Some may hold tholins that paint them red. Others might hide prosolar grains, dust older than our sun, formed in the explosions of long-dead stars. Each one is a fragment of galactic history. Think about what that means. Every interstellar object is a message in a bottle, drifting across light years. Not written in words, but in chemistry, in isotopes, minerals, and molecular fingerprints that reveal how other star systems were born. Some may even contain amino acids like the comets of our own system. If that's true, then these visitors aren't just rocks. They're couriers of possibility, seeds of life wandering between the stars. Oumuamua came and went before we could send a probe. Borisov slipped away into the void, but they won't be the last. Astronomers now estimate that trillions of such objects may wander through the Milky Way, and our solar system will be visited again. The real question is, will the next one be ordinary or extraordinary? A snowball of ice, a shard of alien geology, or something far stranger, an artifact designed to travel forever? As we prepare new missions like the Comet Interceptor waiting to launch toward the next visitor, one thing is clear. The story of comets is no longer just about our solar system. It's about the galaxy itself. Because here's the truth. Comets aren't just relics of the past. They may be keys to our future. For most of human history, comets were omens. Flaming swords across the heavens. Portents of kings rising or kingdoms falling. And while we now understand their physics, the truth is, comets still have power over our destiny. As threats, a large comet impact could end civilization in a single afternoon. Unlike asteroids, many comets approach on long, unpredictable orbits. We could discover one only months or weeks before it hits. As resources, comets are rich in water ice, carbon, and volatile gases. In a future of space exploration, they're not just rocks, they're fuel depots, places where spacecraft could refuel on water split into hydrogen and oxygen. As messengers, every comet is a data capsule preserving the conditions of star systems from billions of years ago. By studying them, we can learn not just about Earth's origin, but about the galaxy's diversity. Comets are threat, opportunity, and teacher all at once. Let's rewind the story briefly. From Rosetta's Philae lander on Comet 67P, we learned comets carry complex organics, including amino acid precursors, possibly linked to the origin of life. From interstellar objects like Oumuamua and Borisov, we learned comets and comet-like bodies drift between star systems carrying exotic chemistry. From decades of observations, we now suspect that Earth's water and perhaps life's first sparks may have arrived from comets. But those are just first steps. The big discoveries are yet to come. The next wave of missions, the 2020s and 2030s, are about to transform comet science. As is Comet Interceptor. Unlike past missions, which targeted known comets, this spacecraft will wait in space until a brand new comet, maybe even an interstellar one, is discovered. Then it will race to meet it. It's the first mission designed for the unknown. NASA's Caesar Comet Astrobiology Exploration Sample Return, though cancelled for now, its goal was audacious: bring pieces of a comet back to Earth. Scientists are still pushing for missions like it. Imagine holding in your hand the ices of the early solar system. Private initiatives. With the rise of commercial space flight, it's only a matter of time before mining companies eye comets for their volatiles. Some even propose comet capture, nudging small comets into stable orbits to become refueling stations. The next 50 years could see us not only studying comets, but harvesting them. The human side of comets, science is one thing, but comets also shape our imagination. Ancient cultures feared them. Some worship them. Even today, when a bright comet like Hale-Bopp or Neowise graces the sky, millions step outside and look up together. For a few weeks, the night becomes a shared theater and the comet a cosmic actor. And then there's myth. The Greeks believed comets were burning stars with fiery hair. In medieval Europe, Halley's Comet was blamed for plagues and invasions. In 1997, the arrival of Hale-Bopp was tragically linked to the Heaven's Gate cult. Comets inspire awe, fear, and sometimes obsession. But behind it all, they remind us that we are part of a larger story, a solar system alive with motion. Here's a thought that sounds like science fiction, but isn't. One day, comets may be lifeboats for humanity. If we learn to hollow them out, comets could become massive space habitats. Their thick icy shells would block deadly radiation. Their water could sustain life indefinitely. Some scientists call them comet arcs, moving colonies drifting between the stars. It's an extreme idea. But so was flying once. So was walking on the moon. If comets hold the keys to interstellar survival, we may one day call them home. There's also a deeper question here. If comets carried the building blocks of life to Earth, did they do the same elsewhere? Imagine millions of comets flung out of billions of star systems, each carrying amino acids, sugars, maybe even more complex molecules. If they rained down on young worlds across the galaxy, then maybe life is not rare at all. Maybe it's common. Maybe we are just one branch of a galactic family tree seeded by cometary messengers. Carl Sagan once said, "We are star stuff." Perhaps more specifically, we are comet stuff. So here we are. We've gone from comets as omens of doom, to comets as cradles of life, to comets as future fuel stations and habitats. And somewhere out there, right now, another interstellar object is on its way. It may look like Borisov, glowing and icy. It may look like Oumuamua, flat and strange. Or it may be something entirely new, something that forces us to rewrite what we know once again. The universe has been sending us messages for billions of years. The question is, will we be ready to catch the next one?